All right, get ready for this one because in today's deep dive, we're tackling something that's, well, a bit unexpected. We're talking about the pH scale, that scale that tells you how acidic or basic something is. But here's the kicker. It was actually invented by, get this, a beer company.
Yeah, a beer company. Carlsberg, to be precise.
Carlsberg. It's pretty wild, right? I mean, who would have thought that something as, well, as enjoyable as beer could lead to such a fundamental scientific discovery?
I know, it's not exactly the first thing that springs to mind when you think about groundbreaking science. But trust me, this is a story you won't want to miss.
It's a fascinating story. We're going to be diving deep into it today. We're exploring an article all about Peter Lorentz Sørensen, the Danish chemist who's, well, he's the guy who cracked the pH code, so to speak.
Exactly, he's the mastermind behind the pH scale. And you know what's cool? Google even dedicated one of their interactive doodles to him and his invention.
Oh, yeah, I remember that doodle. It was really neat. You could sort different foods by their acidity and alkalinity. It was a great way to visualize the whole concept.
It was a fantastic way to make it interactive and engaging. You could see how something like a lemon, which is super sour and acidic, falls on the lower end of the pH scale.
Right, and then something like spinach, which is more alkaline, sits higher up on the scale. It really brought it to life.
Absolutely, it's a great visual tool.
So let's talk about Sørensen himself. This article paints a pretty interesting picture of his life. He was born back in 1868 to a farming family, but ended up studying science. He even consulted for the Danish Navy for a bit.
It's quite a diverse background for someone who ended up revolutionizing chemistry.
Right. And then, after earning his doctorate in inorganic chemistry, he lands this prestigious gig as the head of chemistry at the Carlsberg Laboratory in Copenhagen at just 33 years old.
Ah, the Carlsberg Laboratory. Now that's where the story gets even more interesting.
It wasn't just any ordinary lab, was it?
No, not at all. It was actually funded by the Carlsberg Brewery.
The brewery itself.
Wow. And they had a very specific goal in mind: to brew the absolute best beer possible.
They were serious about their beer. Huh?
Oh, they were dedicated to quality, and that commitment to scientific rigor really set the stage for Sørensen's groundbreaking work.
And they had some impressive achievements under their belt already, right? I mean, the article mentioned that they were the first to cultivate pure yeast.
That's right. It was a game changer for brewing at the time. They also developed something called the Kjeldahl method, a super precise way to measure nitrogen in food and drinks.
The Kjeldahl method.
Yeah, it's a technique that's still widely used today, which just goes to show how ahead of their time they were.
So we've got this top-notch lab, funded by a brewery, obsessed with quality, and then enter Sørensen. What was his focus at the lab initially?
Well, given the lab's purpose, it's no surprise that he was initially focused on fermentation.
Makes sense. He was trying to brew the perfect beer, I imagine.
Exactly. His research delved deep into amino acids and enzymes, those workhorses of so many biological processes. But here's the key takeaway. Through his work, he realized just how crucial the concentration of hydrogen ions was to the activity of these enzymes.
So that's the connection. He's trying to make a better beer
Yeah.
and stumbles upon this fundamental concept of hydrogen ion concentration. And that's what leads him to the pH scale.
You got it. He needed a precise way to measure and express this concentration, and that's how the pH scale was born. It's a brilliant example of how a very specific practical problem in this case, brewing better beer, can lead to a groundbreaking scientific tool with far-reaching implications.
Wow. It's amazing how sometimes the most unexpected paths lead to the most incredible discoveries.
Absolutely. It really highlights the beauty of scientific exploration. You never know where your research might take you. So we're back, diving deeper into this amazing connection between beer and the pH scale. It's wild to think something we see in labs and maybe check when using pool chemicals actually started with someone trying to make a better beer.
I know, right? I think I'll never look at my beer the same way again. But, okay, let's get back to the science for a minute. We keep talking about this logarithmic scale, but I'm still not quite sure what makes it so special or why Sørensen chose to use it.
Oh, it's definitely worth understanding. The logarithmic scale is pretty ingenious. Basically, it helps us measure the concentration of those positively charged hydrogen ions. Sometimes they're called protons too. And the cool thing about the logarithmic scale is, well, it lets us show these really huge differences in concentration using a much simpler range of numbers, manageable numbers.
Okay, I'm sort of getting it, but an example might really help me wrap my head around it. Can you give me something concrete to picture?
Sure, let's think about lemon juice. It's super sour, right? And that's because it's got a low pH around 2, which means it's very acidic. Now, think about baking soda. Baking soda is actually the opposite. It's slightly alkaline with a pH around 8 or 9.
Okay, so one's acidic and the other is alkaline. I get that. But the pH numbers don't seem that far apart.
Ah, but that's the thing about the logarithmic scale. Even though they only look 6 or 7 units apart, that difference actually means lemon juice is 1,000, maybe even 10,000 times more acidic than baking soda. It's a pretty amazing way to show those massive differences.
Oh, wow. Yeah, that definitely puts things into perspective. So that's why this pH scale, even though it seems kind of simple at first glance,
Yeah.
was such a game changer.
It was. It completely changed the way we could measure and talk about acidity and alkalinity. It had a huge impact.
Well, yeah, the article mentioned it's used for tons of stuff, everything from batteries to blood. But to be honest, it's hard for me to see how it all connects.
Let's take batteries, for example. You know, the ones in your phone or laptop. Those actually rely on chemical reactions that are super sensitive to pH. Even little changes in pH can affect how well the battery works or how long it stays charged.
So the pH has to be just right for batteries?
Exactly, just like Goldilocks. And it's the same deal with our blood. Our blood actually has to stay at a very specific pH, slightly alkaline, around 7.4. And if it moves even a tiny bit away from that, it can mess up a lot of important things in our bodies. That's why doctors use the pH scale to check blood pH.
That makes sense. So they can figure out if something's wrong, like if the blood is too acidic or alkaline.
Exactly. They can diagnose conditions like acidosis or alkalosis that way, which can be really serious if they're not caught.
Wow. So this scale that was born from, trying to brew a better beer is now a crucial tool in medicine.
It is. And then there's the oceans. We're dealing with this whole problem of ocean acidification because, well, more and more carbon dioxide from the atmosphere dissolves in the water, and that makes it more acidic.
Yeah, that's a big problem. I've heard it's really bad for things like coral reefs.
It is. Coral reefs are incredibly sensitive to changes in pH. And you know what scientists use to track these changes and see how it's affecting marine life?
The pH scale.
The pH scale. It's everywhere. We've got batteries, blood, the health of our oceans.
I'm starting to see just how fundamental this scale really is.
Yeah.
And to think it all stemmed from research that was just trying to perfect a beer.
It really shows how interconnected different areas of science can be. You know, you might start with one specific problem and suddenly you end up with this incredible tool that has applications way beyond what you ever imagined.
It's pretty mind-blowing, honestly. Oh, before we move on, I was just curious. Did people try to measure acidity or alkalinity at all before Sorensen? Or was he really starting completely from scratch?
That's a great question. It gets at how scientific knowledge builds on itself, you know. Chemists before Sorensen, they definitely knew that some things were acidic, some basic, some neutral, but they didn't have a precise way to measure the differences between them.
So they had a general idea but couldn't actually put a number on it?
Exactly. It was like knowing something was hot or cold, but not having a thermometer to actually tell you the temperature. What Sorensen did was he gave us that thermometer for acidity and alkalinity. He formalized the knowledge, created a system to measure it, and that meant scientists could actually communicate about it in a clear, standardized way.
And now we've got this incredibly powerful tool, all thanks to him. It's really remarkable how much impact this simple scale, just 0 to 14, has had.
It is. It's a reminder that even the most basic scientific tools can be incredibly powerful, especially when they help us understand and measure something fundamental about the world. And in this case, that's acidity and alkalinity, which are everywhere, from the oceans to, well, our beer.
So we've gone through the origins of the pH scale, the science behind it, and even explored all the ways it's used. But now I'm really curious to learn more about Sorensen's legacy, the lasting impact of his work and what lessons we can take away from his discoveries. Let's explore that in our final part. And we're back, wrapping up our deep dive into the amazing world of the pH scale. It's been quite a journey, wouldn't you say?
Yeah, from its humble beginnings in a beer lab to, well, impacting just about every scientific field imaginable.
I mean, it's pretty wild to think that this all started because someone wanted a better beer. Sorensen wasn't setting out to change the world of science. He was just trying to solve a specific problem.
Right, he just wanted to improve things at the brewery. But it's a great reminder that sometimes the biggest breakthroughs come from the most unexpected places.
Totally. It makes you think about the value of investing in research, even when the initial goals might seem, kind of ordinary. Who could have predicted that funding a lab to make better beer would lead to a tool that revolutionized so many fields?
It's a testament to the importance of basic research and just letting scientists explore and follow their curiosity. You never know. What seemingly simple question might unlock a whole new understanding of something.
It also highlights how crucial collaboration is and cross-disciplinary thinking.
Hmm.
Bringing together scientists from different backgrounds like they did at the Carlsberg Laboratory,
Yeah.
that's how you get those truly innovative solutions.
Absolutely. When you share knowledge and combine different perspectives, that's where the magic happens. And in this case, it led to this amazing tool that scientists are still using across all these different disciplines.
We've talked about the impact of the pH scale on chemistry, biology, environmental science, even medicine. But I'm curious, what about its legacy beyond specific applications? What can we learn from Sorensen's approach to science and problem solving?
I think one of the biggest things we can learn from him is the power of thinking clearly and precisely. Sorensen took a concept, acidity and alkalinity, that was pretty fuzzy and made it sharp, quantifiable.
He brought order to the chaos.
Yeah. He created a system that allowed scientists to communicate about these concepts in a consistent, clear way to compare their results. It was a major step forward.
It's like he gave us a new language to talk about a really fundamental aspect of the world around us. And that language is still being spoken by scientists all over the planet.
Exactly. That's one of the hallmarks of a truly groundbreaking scientific contribution. It provides a framework, a whole new way of thinking that goes way beyond the original application.
So as we raise a glass, well, maybe a glass of Carlsberg,
Love
to Soren Sorensen and his incredible discovery, let's also raise a toast to curiosity, the importance of collaboration, and the power of simple ideas to change the world.
Cheers to that. And to the reminder that the next big breakthrough might be hiding in the most unexpected places, just waiting for a curious mind to come along and unlock its potential.